for today's topic, we're going to discuss sequences. Now, let's define what is a sequence.
A succession of numbers in a specific order is called sequence.
For instance, 1, 4, 7, 10, and so on. Each number in a sequence is called term. Sequence is also called progression. We can use a sub 1, a sub 2, a sub 3, up to a sub n and so on to represent our sequence, wherein a sub 1 is the first term, a sub 2 is the second term, and a sub n is the nth term. Given the same example, 1, 4, 7, 10, and so on, let's identify what is a sub 1, a sub 3, and a sub 5. A sub 1 is the first term, which is 1. A sub 3 is the third term, therefore, a sub 3 equals 7. Next, what is a sub 5? As you can see based on the pattern, we can get the next term by adding 3. Therefore, a sub 5 is 13. Given the following sequences, let's observe the difference. The only difference is these dots, meaning we can extend our sequence, we can continue our sequence. That's why in the first column we have finite sequence, on the other hand we have infinite sequence. Now, let's define what is finite and infinite sequence. A sequence with a definite number of terms or limited number of terms is called finite sequence. For instance, where the first and the last terms of the sequence are called extremes, while the terms between the extremes are called the means.
On the other hand, a sequence with no definite number of terms or unlimited number of terms is called infinite sequence.
Examples are, and as I said earlier, these dots represents infinite sequence. In this case, I want you to group the following infinite sequences. I will help you by changing the color. Kindly focus on the sequence having the same color. If you need more time, you can pause the video. Let's focus on the first column. In this example, how can we get the next term? In order to get the next term, we need to add 4 to the preceding term. That's why this is considered as arithmetic sequence. On the other hand, how can we get the next term? In order to get the next term, we need to multiply 2 to the preceding term. And this is example of geometric sequence. Let's discuss further about arithmetic and geometric sequence. Arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant, and that constant is what we call the common difference. Common difference is denoted by small letter d. D equals a sub 2 minus a sub 1. Take note of this. A sub 2 minus a sub 1 is not equal to a sub 1 minus a sub 2. It should be the leading term minus the previous term. And to check the consistency of the common difference, we can also use a sub 3 minus a sub 2 and so on. Or in general, we have a sub n minus a sub n minus 1. Geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a non-zero constant. And that non-zero constant is what we call the common ratio. Common ratio is denoted by small letter r. R equals a sub 2 over a sub 1. Take note of this also. A sub 2 over a sub 1 is not equal to a sub 1 over a sub 2. It should be the leading term over the previous term. And to check the consistency of the common ratio, we could also use a sub 3 over a sub 2 and so on. Or in general, we have a sub n over a sub n minus 1. Let's practice by solving the common difference and common ratio. Using the formula, a sub 2 minus a sub 1. A sub 2 is 11 and a sub 1 is 5. 11 minus 5 is 6. Now, to check the consistency of the common difference, let's use a sub 3 minus a sub 2. 17 minus 11 is 6. And as you can see in this sequence, in order to get the next term, we need to add 6 to the preceding term. Therefore, the common difference is 6. Now, let's solve the common ratio using the formula a sub 2 over a sub 1. A sub 2 is negative 5, and A sub 1 is 1. Negative 5 over 1 is negative 5. Now, to check the consistency of the common ratio, let's use A sub 3 over A sub 2. A sub 3 is 25 and A sub 2 is negative 5. 25 over negative 5 is negative 5. And as you can see in this sequence, in order to get the next term, you need to multiply negative 5 to the preceding term. Therefore, the common ratio is negative 5. Let's have another example. Let's solve the first using the formula A sub 2 minus A sub 1. A sub 2 is 54 and A sub 1 is 56. 54 minus 56 is negative 2. Let's check the consistency of the common difference using the formula A sub 3 minus A sub 2. A sub 3 is 52 and A sub 2 is 54. 52 minus 54 is negative 2. Therefore, the common difference is negative 2. Let's solve the common ratio using the formula A sub 2 over A sub 1. A sub 2 is 8 and A sub 1 is 16. 8 over 16 is 1 half. Now let's check using the formula A sub 3 over A sub 2. A sub 3 is 4 and A sub 2 is 8. 4 over 8 is 1 half. Therefore, we can conclude that the common ratio is 1 half. And this is how you solve the common difference and common ratio.